Class, today we're going to be doing the final lesson of Chapter 8, which is called Factoring Polynomials Completely, but what we're actually going to do today is we're really going to work on the grouping method, and then next week we're going to kind of finish up where it says completely, but you'll see a little bit of this today, okay? So our goal for today is to know how to factor something that has 4 terms, or we often call that a polynomial. So in lesson 5 and 7.6 and 7.7, we've all been dealing with factoring. They've just been kind of giving you different types of problems. 7.5 did not have a coefficient. 7.6 had the number out front, had a coefficient, and 7.7 was your specials. So now the final type is, what do you do if you have more than 3 terms? So it's no longer a trinomial. Well, really the key to grouping is the greatest common factor in pairs. That's really the key that you want to look for in this, okay? So let's just dive in. Let's take a look at number 1 down here. Notice these don't all have a greatest common factor, so there's nothing that I can pull out of all of them. However, if I kind of break it, like right down the middle here, if I kind of break it, notice I do have a greatest common factor in the first 2, and I also have a greatest common factor in the second 2. So let's just do that. Let's pull out the greatest common factor. So between 5x and 15, the greatest common factor would be 5. And then we divide. So if we divide this out, we get x. If we divide negative 15 by 5, we get 3. So that would be our greatest common factor pulled out. Now let's do the same thing over here. Now notice the greatest common factor is not 5. It is 4. So let's pull this out as a positive 4. So if we pull 4 out of here, so if we divide out the 4, we're left over with x. And if we divide negative 12 by 4, we get a minus 3. Now, here is the key. Do you notice that the parenthesis pieces are exactly the same? That is called grouping. So what you do is you put the parenthesis piece together. So you pull that together, and then you jot down what you're left with. So what you're left with goes in the other parentheses, 5 plus 4. Now, many times this will also have a variable in it, and so you would just leave it, but do you see how this can be cleaned up, 5 plus 4? So we could go ahead and make that a 7, and you could even write the 7 first if you want, like that. It's up to you, okay? But what you want to do is you want to put your parenthesis piece together and then put what you're left over with. Okay, so let's try another one. And notice I only have 5 problems here, so I don't have a lot to go over with you. So at any time, if you want to pause the video and try one on your own, you are always welcome to do that. That's kind of the nice thing with a video, is you can kind of tailor it to your own speed. So if we look at number 2, we're going to go ahead and again kind of divide this. I'm going to try to divide it right after the letter so we don't kind of interrupt that symbol there. And what we're going to do is we're going to pull out the greatest common factor of the first 2. So notice those are both divisible by 2. And then look at the letters. Notice this is an a squared and an a, which means they both have an a in common. So if we divide by 2a, so 12 divided by 2, and then if we go a squared divided by a, remember that's actually chapter 6. When you divide, you basically subtract your exponent. So it's like 2 minus 1. And then if we divide 2 divided by 2, we get 1. And then if we subtract 1 minus 1, we get 0. And remember, anything to the 0 power is 1. So we don't even have to write that. Now notice if we were to redistribute, so if I grab a piece of paper here, if I were to redistribute 2 times 6, a times a, and then I distribute again, 2a times 1, do you see how I get the exact same thing back? Okay, so I'm not really, I'm not changing anything. I'm just kind of manipulating the way it looks. Now I'm going to do the same thing with this part. I'm going to pull out the greatest common factor. Now, most of you probably know the greatest common factor is 5. So I'm switching to a pencil here, so maybe don't, just kind of watch for a second. Let's say I pull this out as a positive 5. When I notice they don't have a variable, so it's just going to be a 5. Notice when I divide, negative 30 divided by 5 would be a negative 6a. Notice a negative divided by a positive would be a negative, and then 5 divided by 5 would be 1. Do you notice how my parentheses are very similar, but the symbols are not correct? I need these parentheses to match exactly. So what if I took this out as a negative 5? If I pulled this out as a negative 5, then a negative divided by a negative would make a positive, and a negative divided by a negative would make a positive. Now look at my parentheses now. Do you see how they're exactly the same? That's kind of what you're going for. So you're trying to get these parentheses to be exactly the same. You're grouping them together. So now because my parentheses are the same, I can go ahead and put those down. So 6a plus 1. And then I'm going to go ahead and put what I'm left with. So I'm left with 2a and then the minus 5. Like that. Now, if you want to switch the order, so if you would want to put what you're left with first, 2a minus 5, and then the parenthesis piece, that is the exact same answer. You see how the order is switched. So remember, that's the commutative property. And then one last thing I just want to show you here is if I were to refoil this out. So if I were to refoil this, so 6a times 2a, do my outer, do my inner, and do my last. Do you see how that's exactly the same? Now these two are switched, but that's okay. Notice it's a minus 30, plus 2, plus 2. So that's exactly the same, okay? Now, in these two particular problems, just the way they were written, I do realize that you could have combined like terms. So there is another way that these two could have been done. However, when we proceed on to number 3, you'll notice there is no way to combine like terms. So for instance, on number 2, I could have gone like this, put the 2 together and did a negative 28a minus 5. And then I could have just tried to factor it like that. That's exactly what we did in 7.6. So I realize there is a second way, but the concept now, take a look at number 3. Number 3 has no like terms. You would not be able to combine. Number 4 has no like terms. You would not be able to combine. So you really need to have this idea of grouping down. So again, I only have 5 problems. I only have 3 more to go. So if you would like to pause it and try number 3 on your own, please feel free to do so. Let's go through number 3. We're going to go ahead and just split it like we've been doing. So we're going to split it right here, and then we're going to group them. And remember, the hard copy of these notes is also posted on our class site. So if it's hard for you to see any of the numbers, you can pull it up on your own. But like I said in a different video, these are plus signs. We don't have any divisions in this chapter, okay? So we're going to pull out our greatest common factor, which in this particular case just happens to be the variable d. They both have a d in common. And so now what we're left with, we pulled a d out, so we still have 1 left. And then we pulled the d out of this one, so we have the plus c. Notice if we redistribute, we get this original back, so we know we've done it correct. Now in the second set, notice the greatest common factor is not a letter. Notice it's a number, so we're going to pull out the number, and then what are we left with? We pull out the 2, we're left with c. We pull out the 2, we're left with d. Now, look at your parentheses. They don't look exactly the same because notice how the order is reversed. But remember, the commutative property tells us in addition and multiplication, so up here was multiplication, that we can switch things around and it won't change. So we're still going to put these together. They're still the same. And it's actually more common to write them in alphabetical order like that. So it's more common to put C plus D versus D plus C. But that's, again, that's just kind of being kind of picky, but that's okay. We want to be as accurate as we can. And then what are we left with? We're left over with D plus 2. And so this is what they're looking for. So these last pieces, like right here, this is what they're looking for in your answer. These answers are not just a single numerical number. They're really more expressions. This is 2 binomials. So you just have to get kind of comfortable with that. All right, now the last 2 problems, you're welcome to try them on your own, but I will warn you, there's a small trick at the end. Okay, so let's tackle number 4. It doesn't come to the very end, so if you want to stop it and try it, you could. Okay, we're going to divide it right here, and we're going to pull out our greatest common factor. So once again, we don't have anything numerically as a greatest common factor, but look at that. We have t cubed and t squared. So that means they both have t squared. So I can pull 2 of them out. So I'm going to pull a t squared out, and I'm going to be left with 5t. And then if I pull the t squareds out, I'm only left over with the 6. And again, if you redistribute, you'll get this back. All right, in the second one, man, look at that second one. They don't have anything in common, do they? But if I just rewrite this, where are my parentheses? If I try to do this, you got to be careful because a negative times this would make a negative. But a negative times a negative would make a positive. So you would need to switch this symbol. So what are you actually pulling out? You're pulling out a 1. So the greatest common factor in this particular part, so the greatest common factor is 1. Or if you want to say -1, because I pulled it out as a negative. Okay, remember, the goal is you need to get these parentheses the same. We don't often think of 1 as the greatest common factor, but it does happen. So our parentheses are the same. And then what we're left over with is t squared minus 1. And many of you might stop right here, but this is where the title comes in. The title is factoring completely. This is not done. Do you remember from lesson 7.7? In lesson 7.7, we went over those special tricks. This is a perfect square. 1 is a perfect square. So we have to continue. We have to do our special trick from lesson 7.7. And again, if I was there with you, I would ask you what that trick was. And hopefully you should all be telling me it's when the middles drop. So remember how we alternate our signs to get our middles to cancel. So we would have t times t, and then 1 times 1, and then we would have 5t plus 6. That one just kind of comes straight down. So notice our answer now has 3 sets of parentheses. This only happens if you have a perfect, the difference of 2 squares. It's called the difference of 2 squares. Can I just kind of give you a variation? Let's say our problem would have been like this. Let's say it would have looked like this. Would you be able to keep going? The answer is no. Because if you put 2 plus signs, you're going to get a middle term. If you put 2 subtraction signs, you're going to get a middle term. If you alternate them, a negative times a positive is a negative. So this, you would have to stop right here. What if you had a problem that looked like this? So I'm keeping the first one the same. Minus 10. Would you be able to go any further? I like the minus, so your brain might be thinking plus, minus, but 10. Are there any numbers that will multiply to get 10 that are themselves? So 1 is 1 times 1. 10, I either have to use 1 and 10 or I have to use 2 and 5. But either one of those combinations is going to create a middle term. So the only way that you can keep going is if you have the difference of 2 squares. Both of these have to be a perfect square, and this has to be a subtraction, okay? Now, number 5 follows this rule as well. So why don't you for sure stop it here and try number 5 if you haven't done that yet. Okay, I hope you have tried number 5. So let me go ahead and pull out my greatest common factor. So in the first one, again, I just have my letter, m squared, so I'm left with m minus 2. So I just pulled out what they had in common. And then on the second set here, man, those are some big numbers. But let me just give you a little hint. Chances are this is going to need to be an m minus 2. I need those parentheses to be the same. So I'm going to hope that 96 is divisible by 49. I know they're probably both maybe divisible by 7, but I'm hoping that this is going to work out to be a whole number. 96 divided by 49. It is not. Let me see, did I make a mistake? Oh, yes, I did. Sorry, when I was typing. Oh, that's so my mistake. I'm really sorry. This should have been a 98. Gosh, I'm really sorry on that. That should have been a 98. I must have just hit the wrong key when I was typing. I really apologize. So 98. So 98 divided by 49. It has to be. If it comes out to be a decimal, we wouldn't give you a problem like that. Okay? So we're going to pull out this 49. And so then if we remultiply, that would be a negative 49, and then if we multiply, that would be a 98. Again, I'm sorry, that must have just been my typo, okay? Now notice my parentheses are the same. And then what's left over? So I'm going to put m squared minus 49. That's what's left. And now this is done because it's just singular. But look at that. You see how perfect square with a subtraction? So this can go lower. So we're going to need to go plus and minus. And again, it's just my habit. I usually just do the plus first, but it doesn't matter. And then we're going to go m times m. And then basically the square root of 49 would be 7 times 7. And then this one just carries down. It just kind of follows down. And then this would be your answer. And you could change up the order of these 3 and it would still be correct, but you do need a minus 2, a plus 7, and a minus 7, so you need all 3, okay? And that concludes our chapter 7.